So we have the integral from cosine theta over 1 plus sine theta d theta. What is the problem here? I didn't like a sum in the square root. I don't like a sum in the denominator. That's a problem. I like this with only one term, but with two terms I don't like it. So let's say let u be
1 plus sine theta.
very good, awesome. Du is
Cos theta d theta.
awesome. Here it is. It couldn't be easier. Which function prime is 1 over u?
Natural log.
Excellent. But don't forget the absolute value plus a constant c. So then all I have to do is go back and write 1 plus sine theta plus a constant c. Awesome. Okay, let's look at definite integrals now. Plus substitution rule. So let's choose now from definite. From 59 through 80. The idea is the same, it's just a minor little change. Okay, I'm going to start with 73. In 73, we have the integral from 1 to 2 from x the square root of x minus 1 dx. It caught my eye. Good. Now I have one thing to worry about, which is if this function is continuous on 1, 2. Because if this function is not continuous, I will say FTC is not applicable, and I'm done. I move on to the next example. Between 1 and 2, the function is continuous. What is the domain of this piece? How will I write the domain of this piece? I know we discussed that 3 months ago, but we should know how to find the domain of the square root of x minus 1. What do I have to write?
It has to be greater than or equal to 0.
X minus 1 has to be greater or equal to 0, which means x greater or equal to 1. Awesome, brilliant, thank you. Which is greater than or equal to 1. So this is continuous. So I can continue because the function is continuous. Okay. So we had a situation similar a few minutes ago, similar to this. This one. Blah, 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 blah. So what did we do? So we said let y be
X minus 1?
yes. This is very nice because it happens that dy equals dx. Ah, and you can say, well, what did you accomplish here? A lot. So this will be replaced by dy. Fine. This will be replaced by y to 1/2. Fine. But what about this? Because I can't have x and y in the same integral. So is there a way from here to replace x in terms of y?
Y plus 1.
Yes, awesome. So then x equals y plus 1. So I'm gonna put a triangle, jump over all this. It continues here. Do not copy the limits of integration. Okay. So this is replaced by y plus 1. This is replaced by y to 1/2. This is replaced by dy. Awesome so far. I have all the x's gone. Everything is, each and every piece is replaced by something in terms of y. But now, this is the only difference from definite to indefinite, or from indefinite to definite. When the lower limit for x is 1, what is the lower limit for y? When the lower limit for x is 1, what is the lower limit for y?
0.
Excellent. When the upper limit for x is 2, what is the upper limit for y?
1.
Exactly. We're not going back. Why? Because the answer will be a number. Who cares if I got it in terms of x or in terms of y? Nobody. The answer will be a number. How do I continue? Distributing. So y times y to 1/2 is y to 3/2 plus y to 1/2 dy. And now I know how to proceed. Y to 3/2 plus 1, that's 5/2 over 5/2 plus y to 3/2 over 3/2 from 0 to 1. Luckily, they're polynomials, so to speak. They're not, because power 3/2 and 5/2 is not polynomial. But this is when I plug in 0, it's 0, so I only need to plug in 1. Nice. Flip. 2/5 plus 2/3. So the least common denominator is 15 and 8 at the top. So 16 over 15. So what is the difference? When we are looking at an integral that is an indefinite integral, the answer must be presented in the given variable. We can use any substitution or substitutions down the road, we don't care. The answer has to be in the given variable. For the definite integral, we are not going back because we are changing. You cannot copy the limits here as 1, 2. You cannot, because these limits are specific for x. These limits now are specific for y. And the answer is a number. So please do not go back to the given variable. You don't need to. You continue with y, and you get your final answer. And yes, this is verifiable using the calculator. Okay, so we have time for probably 1 or 2. And that's all I needed to show you or present to you this semester. This is it. So let's choose another. I want to choose 80, unless you have something else in mind. Is 80 okay?
Yes, ma'am.
Thank you. So let's look at 80. We have the integral from 1 to 16 from x to 1/2 over 1 plus x to 3/4 dx. not a friendly situation. So I will say let, I don't know, it doesn't matter to me, u be sometimes, as I said, we may find two different substitutions, one that works better than the other. Let me try one thing. So this is what I don't like because it has two terms in the denominator. So if I have 1 plus x to 3/4, can I determine du? Then I have 3/4 and x to 3/4 minus 1, which is negative 1/4. Yes. And this is dx. Okay, so now in this particular situation, remember everything I showed you, it was very simple to make up a sign or a number, right? We had that -5. Every time there is a constant or a sign, I can always make it up, multiplying and dividing by the same number. Sometimes that may not work, like in this case, it doesn't work because I'm not really getting x to 1/2 to say, oh, that's easy, this is du. So let's see what happens if now, and this is a way of showing you the other possibility, what if I replace or solve this equation for dx? Then I have du over 3/4 x2 negative 1/4. I have to divide by this. Dx is this over this. Okay, fine. Then dx, I flip it 4/3, so I have 4/3. And x to negative 1/4 from the denominator goes to the numerator as x to 1/4 and du. Now, the reason why I don't like this method is because I have x and u in the same expression, so I have to be very careful now. Okay, so let's see. The denominator is our u. dx is this, but it still has x in it, right? But when I multiply, and that's the beauty, of course, they came up, I mean, they used a computer software to do this. So the beauty now is that when I multiply x, so when I don't like showing this, to be honest, so but I have no choice now. So the function is now x to 1/2. The denominator will be replaced by u. dx will be replaced by 4/3 x to 1/4 and du. That's why I don't even want to put it in an integral because that's not legit. And you see what happens? When we multiply these two, we copy the base and we add 1/2 to 1/4, and that is that x to 3/4. And the x to 3/4 is u minus 1. So this becomes a little bit more sophisticated. Okay, so the integral from 1 to 16 from x to 1/2, I'm copying it, I don't change anything yet, x to 3/4 and dx is the integral now when x is 1, 1 plus 1, the lower limit is 2. When x is 16, the fourth of 16 is 2. 2 to the third is 8. 8 plus 1 is 9. So you can determine that. I just want to finish. We can do this problem one more time, but I want to finish it before time is up. So the denominator is u. Then this is that u minus 1, and then du. And of course, there is a 4/3 in front, because it comes from dx. And now how do I proceed here? So I have the integral from 2 to 9 from u over u, which is 1, minus 1 over u du. So this is 4/3 u minus natural log of absolute value of u from 2 to 9. So I plug in 9. So I have 9 minus natural log 9 minus, careful, we have to distribute to both, 2 and plus natural log 2. And this is it. So here, the minor constant or sign that could be made up didn't work. So here I had to go through other steps of finding the integral, using the substitution, of course.